Hello everyone, welcome to my YouTube channel, Know About Embedded Systems. So in today's video, we will learn how to program UART in STM32 microcontroller. So this is going to be a very important video, so please watch this video till the end. So before starting the video, if you are a new viewer to my channel, kindly subscribe my YouTube channel, click on bell icon and share this videos to your friends and colleagues. Let us start the video. Is UART programming. Now let us assume this is my UART which is available in our STM microcontroller, which is having the port numbers PA2 and PA3. So you know that UART stands for Universal Asynchronous Receiver and Transmitter, which will be using our two pins. We'll be having one TX and one RX pins. Using this, we're able to transmit from one device to other device. We're able to transmit and receive the data from one device to other device in embedded system. Now, how to do the programming for that? In order to program, the complete programming structure is divided into three parts. Complete programming structure is divided into three parts, and that I'll be explaining how the structure is defined and how we have to define the program, how to develop. Know which port pins we have to use in order to configure your UART in STM controller. You can see here I have taken the port A and PA2 and PA3. So in our STM32 microcontroller, we are going to use PA2, nothing but port A2 and port A3. These two pins we are going to use to transmit and receive the data. That is the first point. Second point is, so in what configurations we have to do the configuration, in which configuration we have to configure your port A, PA2 and PA3. So that I'll explain. So guys, UART programming is divided into three parts. The first part is, you can see here, the first part is GPIO configuration. Before entering into the UART, we have to configure some basic fundamental configurations of your UART in GPIO as well. The first thing, whatever you are seeing on the screen, we have to enable the clock to the port A. So why we have to enable the clock to the port A? You can see here. So I'm going to use a port A. So why I'm using port A? Because I'm going to use port pins PA1 and PA2. This is the reason. So since I'm using PA2 and PA3, we have to enable the clock to the port A. That is the first and foremost thing you should do in the GPIO section. How can I enable the clock? So you know that already. We have to use the register RCC AHB1 ENR. This register is used to configure the clock, or it is used to enable the clock for port A, port B, port C and port D, and so on like that. This is the first important thing we have to do the configuration under GPIO. Second important thing, we have to configure your mode register. So now PA1, PA2 and PA3 we are going to use in a UART mode, right? Or USART mode. UART or USART mode you are going to use, right? So in order to configure your UART or USART, the first of all you should do PA1, PA2 and PA3 port pins in a alternate function mode. This reference manual I have already explained how to do each. You can see here each port pins are having 2 bits. And using this configuration here, you can see this part, whatever you are seeing, input port, general purpose output port and alternate function. So we have to configure this time. We have to configure your PA2 and PA3 in this mode, alternate function mode. So that means, so you just count it from here, 0, 1, 2, 3, 4, like that. So whichever you are doing, I'm using PA2 and PA3, right? So 0, 1, 2. So that means we have to configure these fields. This is for PA3, this is for PA2. PA2, so count it. So this field is for PA0, this is for PA1, then bit fields from 4, 5 is for PA2, bit fields from 6 and 7 it's for PA3. So these two bit fields I have to configure as 1, 0. This is called as alternate function mode. Now I'll take you to the third and the very important configuration, that is called configure PA2 and PA3 in a USART TX and RX mode. Okay, so now what I did here, so just I have enabled alternate function, but there are totally 16 alternate functions available in this microcontroller. For each port pin, it is possible to configure 16 alternate function. So which alternate function we have to select, that we have to analyze now. How to do? Again, I'll tell you. Function we have to select, we have to come to datasheet. You can see here up. So I'm now This is my reference manual. Reference manual is not required for understanding alternate function, so we have to refer datasheet. Here you can see I have opened the datasheet. Okay, I need to concentrate on PA2 and PA3. This is the important thing. Second, just you go on scanning where our USART, TX and RX functions are defined. Just come from the right, left to right. You can see here. So this is TIM. This is TIM stands for timer here. This is I to S, and here you can see USART, TX and RX. So here, this point you have to stop and you have to see which alternate function it is defined. Right. So alternate function is 7. You need to configure alternate function as 7 in alternate function register in order to configure your UART, TX and RX functions. Right? So how? I'll tell you. So I have found out alternate function register, alternate function name numbering, that is AF7. Right? Now again you need to go back to the user manual or a reference manual. So come to the reference manual. So come to the reference manual and go to GPIO register section. Under this, go to here. You can see there is a function GPIO. So try to understand here now what I'm highlighting. GPIO alternate function register. Okay, so go to the alternate function register. Under this alternate function register, here, this is my alternate function. So in order to configure your USART, if you want to configure your USART register, I have to select alternate function 7. And this alternate function, I have to select to the appropriate port numbers. So whatever you're seeing, this is port PA0, PA1, this is PA1, this is PA2, and this is your PA3. Okay, so for each port, this is PA0, this is PA1, this is PA2, so this is your PA2, and this is your PA3. So like this, for each port pin, for alternate function, 4-bit fields are defined. You can see here there are totally 4-bit fields are defined for each port pin. You can see here, right? 0. Right? So like this, for each port pin, 4-bit fields are defined, and I have to configure the respective alternate function number here in the alternate function register. Right? So I have to use, you can see the bit numbers. Bit number I have to use 8, 9, 10, 11, 12, then 12, 13, 14 and 15. So these bit fields we have to use. That means very simple. How I need to configure, I'll tell you. I need to use the 7 left shift of 8 and then 7 left shift of 12 I have to use. So meaning is like this. So this 7 left shift of this corresponds to this one, and this will corresponds to this. Okay, so this is how we're going to configure our alternate functions. Okay, this is very important. If you're not understanding, so you can comment me, you can write a question in the comment section. I'll try to answer in the comment. Okay, so this is called alternate function mode or alternate function selection in the GPIO mode. So there are 3 parts I told. So one is a GPIO section, and one is a UART section, and one more is UART transmitter and receiver section. So we have done all these three. Port configuration I have to do in the UART section. You can see here. So UART section I have to do. In order to do that configuration, again I need to follow 2 to 3 major steps. The first thing is I have to enable clock to USART. In order to enable the clock to the USART, I have to use a register called APB1ENR. So this register is responsible for enabling the clock for peripheral buses. Okay, so in this I have to use. And next important thing is baud rate. So what is baud rate, why it is used, all these things I have explained in a UART theory part. You please watch that video as well. I'll update the link in the description box. Now in order to calculate the baud rate, so you can see this is the formula, simple formula it is. So the UART baud rate is equal to You can see the UART baud rate is equal to, or UART baud rate divider is equal to peripheral clock divided by baud rate. 16 megahertz here, and I want to configure my baud rate at this value, 1,15,200. Substitute these two values and find out the baud rate divider value. That you will get 138.88. It's equivalent to 139. So this value we have to load it to the register like this. USART to BRR. BRR stands for baud rate register. Baud rate register it is, right? Rate value. And third thing is we have to enable three important things. You can see here. Point number 3 you see here. We want to enable USART, enable TX function and enable RX function in the register USART to CR1. UART CR1. Under this UART CR1, so we want to enable, yeah, you can see here bit number 13 we have to enable. Bit number 13 stands for UE. UE stands for UART enable, and then we have to enable bit number 2 and bit number 3. Bit number 2, bit number 3, bit number 13. Bit number 2 talks about receiver enable receiver. Bit number 3 talks about transmission enable, and bit number 13 talks about enable UART, complete UART you need to enable. These 3 bits we have to use in the programming in the register called UART TX and RX function enable UART CR1. So this is your main UART configuration, and in order to transmit data, you can, 2 more points we have to do. If you want to transmit a data, we have to load the data into the UART data register like this. It is USART TX. USART DR stands for data register. Whatever data you want to transmit, the data will be loaded to DR. Okay, and then finally, if you, after loading, we have to check the monitor the transmission status, and you need to check bit number 7. So bit number 7 talks about, you can see here what it talks about. Bit number 7, transmission data register empty, or you can use even bit number 6 also. Bit number 6 talks about transmission completion. Bit number 7 talks about transmission data empty. So you can monitor any one of the bit in order to check whether transmission completed or not under the UART status register. Okay. So this much configuration we required before going to the programming. After, if you do all this programming in your embedded C programming, so then definitely your UART will start functioning and you're able to transmit and receive the data. So this much theory before entering into the program. So in the next video, I will show you how to develop the programming for UART under STM32 microcontroller. So I hope this video is an informative video. If you feel this video is an informative video, please click on like button and subscribe to my YouTube channel, and click on bell icon and share this video to your friends and colleagues.